Today we're going to continue looking at triangle congruence, learning about some more of those, what I call shortcuts. We've worked with two of them so far, side, 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 and side, angle, side. Today's lesson, we're going to work with two others. We're going to have angle, side, angle, and angle, angle, side. So again, the order that you have those continues to be very important. You can see with the two that we're working with today, both of them have two angles and one side to be congruent. Where that side is in relationship to the angles is important. If the side is between the two angles, we can use angle, side, angle. If the side is not between the two angles, then we use angle, angle, side. So, looking at angle, side, angle, if you open up that flap, it says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So in your interactive notebook, you have two triangles. Mark the sides that you see marked up here on the board. So when you look at those markings, you will notice that the side marked is the side between the two angles. It's the side that the two angles share. Okay, so that is the included side. If either one of the other pairs of sides were marked, then it would not be angle, side, angle. Okay. The side is directly between the two angles. So that's what we need for angle, side, angle. For angle, angle, side, our theorem says,
writing down the last one.
Yeah. Oh, I didn't even realize.
Yeah, I didn't know the congruency stuff.
I could. Oh.
okay, we just need to be marking, putting the marks in our pictures. You just mark it in your pictures. So the angle markings and the tick marks on the side is what you need to. So what's your question, Simon?
All right. So what does it prove that is congruent? Does it prove that? I'm confused.
Because we know these three things are congruent, that's enough to say that the two triangles are congruent. Okay, so the two triangles are exactly the same. But instead of having to show all three pairs of angles and all three pairs of sides like we did in that first lesson, okay, we have these shortcuts that we can apply. Okay? So with angle, angle, side, if two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So again, order matters. So this time, when we look at our picture, we still see two angles and one side marked, just like we did before, but the location of that side is different than the previous. Okay? So this time, the side is not between the two angles. Okay? The side is not between the two angles. So that's when we use angle, angle, side. Okay? Another key word here is that those non-included sides need to be corresponding, which means if we took what we do know and matched it up, so laid those two triangles on top of one another, the side that we have has to be the same. Okay? So if I took triangle ABC and flipped it over, I could lay it on top of the other triangle. And when I did that, Angle B is going to go over to E. A comes over to D, which means the side AC is going to lay on top of side DF. Okay. If I look at my my congruent statement, those pieces match up. Side AC is the first and last. DF is the first and last. Okay? So we always have to look at both triangles and compare them. Not just look at one and say, well, I have angle, angle, side. Okay, side's not in. Because it could be that in the other picture, they did mark the included side. Then you would not be able to prove that they were congruent. Okay, so always look at both of those triangles. So those are the two shortcuts we're going to focus on today. So if you flip to your proof book. So just as before, we always start our proof with the given. So I'm going to take my first given statement. Segment QR bisects angle PQS. And that is given. So as I said before, when we're going through these proofs, if we want to prove a triangle's congruent, we need 3 congruent statements. Okay? This given statement did not give me a congruent statement. So there's a reason they gave it to me. So I need to look at it. If I look at that statement, I have angle PQS. So this big angle PQS is being bisected by segment QR. So if it's being bisected, what does that mean? It's being cut in half or into 2 equal parts. So I know those 2 angles are congruent. I need to write that down. So angle PQR is congruent to angle SQR. And what is the reason for that? Okay. Definition of, I'm going to use the angle symbol for angle bisector. That way it fits in there better. Definition of angle bisector. Okay, so there's one congruent statement. I've got one congruent pair marked in my picture. I've got another given statement that I can write down. Angle PRQ is congruent to angle SRQ. That's given. So I want to mark that in my picture. Angle PRQ and angle SRQ. So there's a second congruency piece that I know. I'm done with my given. So what else do I know?
So, I just have a question. So
Okay.
we can flip those 2 around, right? The given and the definition of
Right.
We can flip those around.
Yes, you could have started with the given, listed both given. Okay. What I find sometimes happens is if you write those 2 given down, then you kind of forget about this top given and you don't do anything with it, and then you're kind of stuck on what to do. Okay, so that's why I like to follow that up. When I see bisects, I know I need to use that definition. But yes, you could have your 2 given statements first. So that's all the given information I have. What else do I know looking at my picture? I have that shared side. So I'm going to mark it in my picture and write it down. Segment QR is congruent to segment QR, and that is reflexive. So that's my third congruency statement. I've got 3 things marked in the picture. If I look at my triangle on the left, I see angle, side, angle. When I look at the right, I see angle, side, angle. So it works on both sides. So angle, side, angle allows me to prove that triangle PQR is congruent to triangle SQR. So again, we need to see 3 things marked in our picture. We need to see 3 congruency statements so that then we can prove the triangles are congruent. Second proof. Again, we'll start out with the given. Segment AC bisects angle BAD is given. So we see, again, lots of repetitive statements being used in these proofs. Again, we've got an angle bisector. When I look at what I'm talking about, I have angle BAD, which is this angle on the left. AC is bisecting it. So that means I have 2 congruent angles. So again, I like to flow with this rather than skipping ahead to my next given. But you could go ahead and write your next given before you work with those bisectors. So I'm going to write down angle BAC is congruent to angle DAC. And again, that is my definition of angle bisector. So there's one congruency statement. Second given, segment AC bisects angle BCD, which is my other given. So when I look at that, angle BCD is this angle over on the right side. It's being bisected by AC. So that cuts that angle into 2 congruent parts. So angle BCA is congruent to angle DCA. And again, that's definition of angle bisector. So there's my second congruency statement. That's all I have given. What else do I know looking at my picture? Simon, we need to wake up and pay attention, please. What do we know, Michaela?
That AC is equal to AC.
Okay. We again have that shared side. So we're going to write that in. So AC is congruent to AC. That is that reflexive property. So that's our third congruency statement. 3 pieces marked. Again, when I look at the top triangle, I have angle, side, angle. In the bottom triangle, angle, side, angle. So I know that triangle BAC is congruent to triangle DAC. AC.
You wrote down side angle sides. Angles.
Oh, I'm sorry, thank you.
Yeah.
Angle, side, angle. So these two proofs worked with that angle, side, angle. The side is between the two angles. The next two proofs, looking at the title, we are going to be using angle, angle, side. So our side is not going to be between the two angles. Yet again, I will start with my given. Segment SR bisects angle QST. So again, we've got that angle bisector. QST is being bisected by SR. So that tells me that I have congruent angles. Angle QSR is congruent to angle TSR. And again, that's my definition of angle bisector. My second given is angle SQR is congruent to angle STR. That is given. So when I mark that in my picture, SQR, so angle Q and angle T are congruent. So I have two congruency statements. I need another one. What else do I know to be true?
Wouldn't it be that SR equals SR?
Yep.
Which is reflexive?
So again, we see that reflexive. SR is congruent to SR. Simon,
I'm away.
you need to be writing this down. That's reflexive. So that's my third piece of information. Okay. So again, I have two angles and I have one side. But when I look, my side is not between the angles. Okay? So it's not angle, side, angle like before, because my side is not between the two angles. Okay? If I were to fold this on the shared side, my corresponding parts would match up. So I know that triangle QSR is congruent to triangle TSR, and that is angle, angle, side. To be able to use angle, side, angle, I would have had to know SQ and ST. Okay, that side is between the two angles. This one is not. So it's angle, angle, side for that proof. Last proof for the day. First given, angle XWZ is congruent to angle XYZ. That is given. So I'm going to mark it in my picture, angle W and angle Y. My second given is that segment XZ bisects angle WXY. So when I look at that statement, I have angle WXY that is being bisected by segment XZ, which means that I have angles that are congruent. So angle WXZ is congruent to angle YXZ. And again, that's my definition of angle bisector. So there's my second congruency statement. What else do I know by looking at my picture? Again, I've got that shared side. So XZ is congruent to XZ, reflexive. So that's my third congruency statement. When I look at the triangle on the left, I have angle, angle, side. If I look at my other one on the right, I have angle, angle, then the side. So I know that my triangles are congruent. XWZ is congruent to triangle XYZ, and that's angle, angle, side.
Yep, in the third statement, you've had WZX instead of WXZ.
No, because the angles have the vertex X. Okay, so it's these two angles down here. Okay, so we need to have that X. Okay. So that is it for today's lesson.